Number 14. 14 kind of works off of number 13, so maybe you'd want to review number 13, because with number 13 we came up with the current through the battery, and which we said was 2 amps, right? And if you look through number 13, it'll explain how we found that. But for number 14, we have the same situation with 3 resistors. R1 has a resistance of 5 ohms. R2 resistance 3 ohms. R3 4 ohms. Voltmeters connect in parallel to resistor R2, and we're measuring 6 volts here. What's the net voltage in the circuit? All right, so we know the voltage is the voltage in the circuit is going to be the sum of all the voltages that are dropped across all 3 resistors. So since we know the current in the circuit from problem 13, we can say, okay, let's solve for the voltage dropped in each resistor. So we already know that 6 volts is dropped for the second resistor. They gave us that. All right, so we can use V equals IR and solve for the voltage drop in the third resistor, which would be voltage is going to be 2 amps, because that's the current through the circuit, times the resistance of 4, and that's going to be 8 volts. And we can do the same thing for the first resistor, and we're going to get 2 times 5, and that's going to be 10 volts. So we know that the total voltage drop for all 3 resistors is going to equal the total voltage coming out of the battery. So we literally just have to add those 3 up, and when we do, we have 24 volts.